அகில இந்திய கட்டணக் கழகம் கோவை மையத்தின் மூத்த உறுப்பினர்கள் உள்ளிட்ட அனைத்து உறுப்பினர்களையும் இந்த நிகழ்வில் இணைந்துள்ள அனைத்து கல்லூரிகளின் பேராசிரியர்கள், ஆசிரியர் பெருமக்கள் மற்றும் மாணவ செல்வங்களையும் மாலை வேளையில் வருக என வரவேற்று இன்றைய தலைப்பானது கோல்டன் இயர் ஃபார் ப்ரீகாஸ்ட் காங்கிரீட். மிக அற்புதமான தலைப்பு. நிகழ்காலங்களில் ப்ரீகாஸ்ட் காங்கிரீட் என்பது மிக பிரபலமாக நமது நாட்டில் பிரபலமடைந்து வருகின்றது. ஆகவே இந்த பொருத்தமான தலைப்பில் இன்று நம்மிடையே உரையாற்ற வந்துள்ள என்ஜினியர் தினேஷ் குமார் பண்டாரி அவர்களை மீண்டும் ஒரு முறை வருக என வரவேற்று அவரை இந்த அவைக்கு அறிமுகப்படுத்துமாறு டாக்டர் இன்ஸ்டிடியூட் ஆஃப் டெக்னாலஜியின் சிவில் துறை தலைவர் டாக்டர் முத்துக்குரி அவர்களை கேட்டுக்கொள்கின்றேன். நன்றி, வணக்கம்.
I'm happy introducing today's guest, Mr. Dinesh Kumar. Bhandari is a PRECAST specialty engineer with more than 15 years of global experience with PRECAST content. He has a BE in civil engineering from Bhandari University, Coimbatore, and MS Structures degree from University of Houston, Texas. Employed in the US PRECAST industry at various levels for 8 years before returning to India and joining Teammates PRECAST as the technical manager in 2012. The last position held with Teammates was Director of Technology. As of November 2019, he has relieved his full-time duties at Teammates and is currently the Managing Director of Concrete Curations Private Limited, an architectural and engineering firm which provides specialized PRECAST engineering and design services for the Indian as well as the American companies. He has a professional engineer license in the state of Texas, USA, as well as a chartered engineer licensor in India. Affiliated with Indian and international organizations dealing with concrete such as ICI, PCI, and XID, etc. We are happy to have you, sir. Thank you for accepting our invitation. Kindly take over the session, sir. Thank you.
Can you all see my screen?
Yes, sir. It is visible.
Okay, wonderful. So thank you for giving me this opportunity, everyone. I'm delighted to be able to present this PRECAST technology to everyone here. I'm sure most of you already are aware of this technology, and so my presentation is focused more towards the current times, the COVID times we call them. So how it affects the construction industry as a whole, and how PRECAST is a prime market right now, and that's why the topic of my presentation is a golden year for precast concrete. So I feel this is where the industry is going to see a major shift into off-site manufacturing, into prefabricated precast structures, whatever. I am associated with precast more so than prefabricated steel or whatever, but I feel the industry as a whole, the off-site manufacturing industry as a whole, is going to gather speed after all of this is said and done. So I'll start my presentation. So today's agenda will be, just where are we right now in the COVID state of affairs, and about us, about myself, our company, and what, why, how precast, the history of precast, the synonyms and the process, and just what a typical precast manufacturing facility looks like. And then I'll get into why I believe 2020 is the golden year for precast, and discuss about how the innovation has happened and how the precast is an emerging market in construction, and then the closing statements and all that. So the COVID state of affairs. So, okay. So before COVID, I think probably in the last part of last year, in the ending part of last year, the construction industry started slowing down, and it was not doing well. I think a lot of projects were starting to get on hold. A lot of projects were starting to cancel. The government spending reduced, and all that. But now this crisis will accelerate change. So we have scarcity of labor. We have people moving around. Some people have left, and some people have gone back to their roots. So there's a lot of shifts which have happened in the construction industry, and this shift will take place in a radical way, and radical shifts.
சார் என்னாச்சு
சார்? ஐ திங்க் ஆடியோ கொஞ்சம் ப்ராப்ளம் ஆச்சு. ஸோ லெஃப்ட் ஆகிட்டாரு, திருப்பி மறுபடியும் ரீஜாயின் பண்ணுவார்னு நினைக்கிறேங்க. கைண்ட்லி வி வெயிட் ஃபார் த செஷன் ஆல் த பார்ட்டிசிபென்ட்ஸ். கார்த்திக் சார் கால் பண்ணி பார்க்கலாங்களா சார்?
சார் ஜாயின் பண்றாருன்னு நினைக்கிறேன்.
ஓகே,
1 minute வந்துருவார்.
Hello.
Yes, sir.
Yes, I'm sorry. There was some disruption there. So I'm going to share my screen right now. Okay. Is it visible now?
Yes, sir. Visible.
Okay. So I'm really sorry. There was some stuff which happened and I couldn't get. So I think I was in the beginning of this slide and I think it got cut. So I was saying the construction industry was not doing well even before COVID. The crisis will accelerate this change. So the change in the radical shifts will take place once we are out of this situation right now. And there's a multi-billion-dollar profit pool which awaits the disruptors. They always say early adopters will thrive and they'll survive better than the late bloomers. And so people, the construction industry as a whole needs to adopt the changes which are happening in the industry now. And there will be ample opportunity for private equity investments and money coming in from other industries. About us, Concrete Curations, we are an architectural engineering and consultancy firm, and which provides curated precast engineering design services, along with process management for offsite manufacturing facilities. I am a precast specialty engineer. I have more than 15 years of global experience with precast concrete. I was in the US industry for about 8 years after completing my master's in the US. And from then, I moved back to India and joined Teenage Precast, one of the leading precast companies in India right now, as their head of design technical manager. And last position I held in 2019 was I was the director of technology. And then somewhere I wanted to start my own design firm and all that. So, currently I am the managing director of Concrete Curations, and my wife, she's an architect and she's the executive director as well. I have a professional engineering license in the state of Texas, USA, which is the PE license in US. And I am a chartered engineer here in India as well. That is about us. Now the topic, why, what, how precast. So I think everybody knows what precast is. Precast is basically off-site manufacturing of concrete structures, which are the structural elements, all the elements, beams, columns, walls, slabs, stairs, everything is manufactured in a precast controlled factory environment and moved to the site, and it's much cleaner, much better in terms of quality, in terms of efficiency and all that. So it is a radical shift from the convention. So the conventional brick and mortar, conventional concrete mixing and site, which is moved to RMC, and then I think RMC now should move to precast. So you don't need to pour concrete at site. Everything can be done in the factory. It's an innovative process, which will reshape the construction industry. I say it's an innovative process because India has not adopted this process yet. There's still a lot less players in precast than in the general conventional system. I think right now it is an expensive technology to adopt. That's what people think. But once I think people need to sit together, understand what are the needs, and see how it can be solved using precast. It is an emerging market with opportunities and challenges. Of course, every market has its own challenges, and so that I'll explain that in the future in the further slides. Why precast? Industrialization is the key to achieve mass production. So, people talk about scalability. We can produce regular using conventional methods. You can only produce so much. Using precast, you can scale up pretty fast. There are different concrete available where it can fasten the whole process of construction, and which can give you huge results in terms of the mass of production. And why is one of the things is India needs to build at least 25 million houses in the next decade. I would think it's more than that because there's a lot of shifts moving towards the bigger cities. People earning more, their income is generating, so they need a proper house, they need a cleaner house or whatever. So India needs to build so many houses, and that is where precast comes in. It is disruptive as a process as well as it is sustainable, and I'll talk about it more. So how can precast be done? Precast, it's a proven technology all around the world. We just need to adopt. In the US, in Singapore, in UK, in Europe, everywhere, it's been being used for more than 50, 60, 70 years. But in India, it's probably been prevalent for the past probably 10 years or so. I'm talking about the building construction. It is pretty widely used in the infrastructure, in bridges, and other, non-structural precast, which is done. But in the building technology, it has only come to India probably in the last 10 years or so. How is it possible? Again, standardization, modularization, and knowledge sharing. So, we don't need different shapes and sizes of houses everywhere. If we can standardize some of the stuff, I think we can, the scalability is possible easily with repeatability. So once you repeat the process, repeat the elements which you produce, I think we can easily scale up the production of precast. Modularization again comes in mind where if the containers, the ship containers can have a standard modules, standard size and shape, so they can be stacked on each other. Why can't houses be modularized? Why can't shops be modularized and stuff? So that needs to happen. And the next thing would be skill development, manpower training, and partnerships for scalability. You need a partner who has money, and you need a partner who has the technology. And if both of those can come together, this can be easily scaled up. So this is how it can be done. The history of precast, like I said, it's not new. Precast blocks were founded by the ancient Roman Empire. They were used in Australia in 1904. In England, they had precast panel buildings constructed in 1905. It went to the US during the gold rush in 1910. And, slowly, pre-stressed concrete was developed by Freycinet in 1928. And I think pre-stressed concrete was a great boon to precast, where the value addition happened, where you could go more length, more spans, the bigger spans, and higher walls, higher columns, whatever. And in the 1950s, the PCI, precast pre-stressed concrete, was invented in the US, and PCI was formed during those years and stuff. And in India, it started in the 1980s, where segmental bridge construction started using precast modules, standard modules, and they were post-tensioned at the end. So I think 2008 is when I say the commercial precast projects starting in India. There was a factory in Chennai, there was a factory in Pune, which were the first two ones coming around in that time frame. And currently, there are about 25 to 30 precast factories which are up and running all over India. When I mention precast concrete factories, I'm still talking about structural precast, building precast, not Hello.
Sir, yes, sir.
Can you hear me?
Sir, yes, sir.
Yeah, I'm sorry. Some things going on with my computer. It's restarting it.
Again,
I don't
it
know
is
what happened.
restarted, sir.
Something crashed again. So I just called from the phone. I'm really sorry. This is I think the first time. I don't know why it's happening, but it is happening. So I would need to find a solution for this. Anyway, so I was talking about the synonyms for precast and a new term called PPVC, which is prefabricated volumetric construction. And there are modular concrete, modular structures. There's tilt wall constructions. Back in my system right now. So.
Hello, sir.
Yeah.
Sir, is able to restart your computer or what we can do, sir?
Yeah, it is. It's just
Because it is
started
not
again.
audible.
So I'm just opening up.
Okay, sir.
Okay.
Sir, no problem. We'll wait. Okay.
Give me 2 minutes.
Thank you, sir.
Okay, am I back?
Yes, sir.
Yes. Yeah. Okay. So I'm not sure if it is the presentation mode or something. So I'm just going to keep it here. I won't make it full screen or whatever. Something is going wrong there. So I was talking about the synonyms of precast. One is the common term used with steel and wood is the prefabricated structures, whatever. PPVC, which is prefabricated, pre-finished volumetric construction, which is a 3D molds integrated with other finishes and stuff. offsite construction, modular construction, all that. So the process of precast. So this here is the process we use for precast is the feasibility studies, which includes the pre-sales and the concept design. Then we get into full-fledged design and detailing, which includes structural analysis, building information modeling, and creating shop drawings from the BIM models. Next comes in the planning phase, where we have project management and create Gantt charts and production charts and all that, and the MIS report, management information system reports. Then comes the production, where more preparations, DPRs, daily production reports, QC checks, and raw material planning happens. The transportation is done after that, which is into stockyard management and traffic management, logistics. And then the erection activity, which has the site management and staging areas, safety standards, and grouting of precast elements together. Then the finishing activities, which is parallel with this, is the waterproofing, cleaning, and handover to the subcontractors. So this is the overall process of a precast project, which is compressed by more than 50% than a regular conventional system. This is one of the precast factories I worked with Dinesh, and this is their factory in Kangayam, which is about 70 kilometers from here. And so these are the different areas, the different stuff which is needed for a precast factory. To start with, its concrete batching plants are here. This is the production area. We have two bays, which is one for hollow core slabs, which are pre-stressed slabs, and one is for all other elements, which is walls, columns, beams, all whatever. And then this is the steel fabrication, where steel is tied and cut and all that happens here. There's the finishing area right here, and then the regular stockyards on the left, on the right here. There is a maintenance shed where all the machines get maintained, and the employee wellness, which is the canteens and hostels for the employees, and there's the logistics, which trailers are parked here and they come in and go wherever. So this is what a typical precast factory should look like, would look like, even if you go anywhere in the world. So this is how it is typically laid out. The precast factory equipments, these are the major equipments which are used in precast factory, starting with concrete batching plant and the distribution system. So what the distribution system does is it takes the stuff from the batching plant to the molds, and it hardly takes about 5 minutes to do that. The next comes in is the large span factory shed, the overhead cranes, the gantry cranes, the stockyards, which I just showed you the photo of. The production equipments, which include tilting tables, flat tables, other beam column molds, all that. That is for the precast production equipments. The hollow core equipment includes a machine called extruder, which and steel beds, the flat beds of about 150 meters or so. Then comes in the transportation equipment, which is the flatbed trailers and A-frame trailers. And at site, you have multiple different cranes, mobile cranes, crawler cranes, and tower cranes. So these are some of the photos of that. This here is the concrete batching plant, and this is the distribution system. This is called something called a flying bucket, which takes the concrete from the batching plant into the precast factory in the linear direction, and this is something called a spreader, which takes it in the transverse direction, which this pours into this bucket here, and this goes in the Y direction. If you think this is X, this is Y. So you can cover the whole factory shed. This is a typical tilting table. Most of the panels or wall panels are poured flat, and then you tilt in place, and you demold the panels from there. This is a vertical casting machine, which is called a battery mold. There's 10 cells or 20 cell battery molds available, and you cast panels inside of these cells, pour concrete from the top, and They have vibrating systems. They have curing systems and hot water, steam curing systems and all that in the machine. This is the hollow core production equipment right here, which I was talking about, the extruder or the slip former. And these are the long concrete beds where concrete is poured, and it kind of just slips away. And we manufacture 150 meters of pre-stressed slabs and cut them to your required dimensions. And then these are the A-frame tailors, which are specialized for precast, shipping it vertically standing up, so you can minimize the transportation and handling and all those cracks develops due to that. And these are the cranes at the site. This here is the crawler crane here, and this is the tower cranes. So these are the equipment used for precast factory. And then the precast concrete products, which are typically used in most of the building elements, start with slabs, so hollow core slabs, filigree slabs. Filigree slabs are half slabs basically, which act as a concrete form, if you will, and you can pour concrete on top and connect everything together. And then the double T's are basically if you think, two T's put together, and they span much larger than the hollow core slabs. Hollow core slabs are used up to about 15 meters or so, and double T's are used anywhere from 10 to 20 meters. Then the wall panels, people manufacture different shapes, sizes, thicknesses, all that, and they manufacture insulated panels, which there's a styrofoam board in between two layers of concrete, and which gives you very good insulation. PRECAST is done using, they use cladding panels, which if you have a conventional building or if you have a steel building, you can use these panels to cover up your facade. And then there's retaining walls, retaining panels, which, if you go into basements and stuff, you can use precast panels to retain earth, and they can be designed for any height and any thickness. Then there's columns, which some manufacturers produce single floor columns with corbels, without corbels, and some people produce multi-floor columns, and you have the corbels for the beams to rest at each level, and they connect to the column using different connections. They manufacture beams, which are pre-stressed beams, inverted T-beams, which is for the hollow core slabs to rest on, and different conditions of the end bearing, which is a fixed condition or the pinned condition. Stairs, people manufacture different shapes and sizes with landings, without landings. The other products which goes with the precast factories and which are easy to do are boundary walls and footings, small footings. They do trenches and ducts and stuff. So these are the photos, some of the photos I collected from my previous projects and stuff. And so this is the hollow core slab right here. Once it's cut, these are wall panels. As you can see, it's one of the traditional designs we've used. We've incorporated that in the mold itself. So you don't need to do finishing activity at the site. These are columns of various shapes and sizes, with corbels and connections. And this is the inverted T-beams, which is used in the site. Stairs, again, you can see stairs with landings here. The other products, trenches, ducts, whatever. So that's the concrete, precast products which are used for the building industry. Connections, we typically try to emulate conventional systems when we do connections. This is one of the pinned connection, beam to column connection, which is pinned here. Hollow core slab, beam column connection here. A beam to beam right here, and a column to foundation right here. So this is a wall panel here. The slab comes in, and the next wall panel comes in, and with dowels here. And this is a wall-to-wall connection horizontally, where we have wire loops coming out of the edge, and a bar is put, and this is grouted. Stair sitting on a beam, whatever. So these are typical precast connections which is used, and it's not like these are available everywhere, and you can find it on the internet. What kind of connection you need, what kind of forces you need to transfer with these connections. So pretty simple stuff here. The next, I'll get into the innovation metrics and why I feel precast is the way forward. As I said, it is disruptive and it is sustainable. That's what precast is, and so it has a 50% savings in the construction time. You can easily reduce your time from the conventional systems by about 50%, and the reduction in material and labor is at about 30%. So although it's disruptive, it is sustainable. They're reducing the labor and the material. So at this time, we don't have resources, we don't have labor. And so precast is the way forward. If you look at the other perspective of it, why is it disruptive? Because faster scalability than any other construction technology. There are various new technologies available, aluminum formwork systems, tunnel formworks, so many other technologies available. But what separates precast against those other technologies is precast is much higher. It has a very high scalability. We manufacture precast. We demold within 6 hours, 8 hours. So you can get 3 shifts in one day, and you can manufacture 3 panels in a single mold in a day. And so it's faster than any other technology out there. So it is disruptive. How is it sustainable? That it enhances the life of the building. Typically, if you're looking at a 50-year building lifespan using precast, it's a denser concrete. It's manufactured in a controlled environment. It's a higher grade of concrete, and it's poured horizontally most of the time. We don't pour vertical, so there's very less pores inside the concrete. So it increases your building the lifespan of the building. And we want to build faster, we want to build better, and we want to build easier. And that's why my thing is precast is the way forward. So there are radical shifts which are happening in the construction industry, and these are some of the ones I listed here. That product-based approach. I was talking about modularization, standardization, and all that, and instead of reinventing the process, reinventing the wheel every time, I think we will shift into product-based approach soon. So precast companies will start displaying houses in their yards, and people can go and pick and choose. You need a 1-bedroom house, you need a 2-bedroom house, you need 2 floors, 3 floors. They will have a product-based approach and try to use the same molds, repeat the molds, so that that's the way forward. Specialization. There's always a thin line between what services you offer. Typically, precast companies are specialized in precast, and I think that should be their core business, and that is what they should sell. They should not try to do all the others or a package deal and stuff, because they don't have expertise in that. They don't have experience in that. So typically in US, in China, in bigger economies, there is the GC, which is the general contractor on a project, and then he appoints or he selects various other subcontractors or specialty contractors, and precast is one of them. And so currently that approach is not being taken in India right now, and I think that is where we are moving, is where precast contractors will be considered specialty contractors, and there will be a general contractor on board, and he will manage all the other contractors and do that. The next is value chain control and integration with industrial grade supply chains. What I mean by this is that, there is, I talked about the precast process, where from the initial pre-sales to design to planning to production, all that, if a precast company is able to control all these value chains in one go, instead of relying on other businesses, other engineers, other transporting companies, other contractors to do the erection, that will slow down the process. And, PRECAST is by, saving time, 50% of the time is saved. So that value chain control in the process is very essential moving forward. This will be a shift. Most precast companies will start using their own resources for end-to-end solutions, and integration with the supply chains, and that's industrial grade supply chains. We have we have Amazon, we have the postal systems and all that. So it's all integrated, where if I want to ship something from here to Delhi, it goes in a matter of 3-4 days, it can go. And so that shift will happen with precast as well, where other players will come in, and this will just move around very easily. Consolidation will happen. There will be some companies which will not be able to sustain losses for a long time, and they'll probably fold or they'll sell or whatever. There's so much consolidation happening in India right now, the Ambanis, the Adanis and stuff. So I think that will happen in the construction industry as well. Smaller players will sell out their businesses, and that will happen. So the next one is customer centricity and branding. So, customer is king. So that focus into customer centric products, projects and processes will happen soon. And people will invest in technology and the facilities. And that's where the offsite manufacturing facilities will start coming up. And, even the shift from China to India, factories are popping up in India right now. So even that shift is happening. And so even in the construction industry, the shift will happen soon. And people will invest in human resources. Precast factories need skilled people. They need higher skill level than general construction, because you have one person doing multiple jobs. You don't have thousands of laborers. You hardly have about, say, 250 to 300 laborers in a precast factory, and they have multi-skill set. And so companies will invest in human resources where they can retain people, they can upskill them, they can use them for various jobs out there. Internationalization, I think that will, with COVID, that is slowed down right now. People are focused more so in their own regions. The Atmanirbhar Bharat, the Make in India, all that. So I think that kind of will slow down a little bit. But the sustainability, that's I was telling, that is a major part of precast. Is it's sustainable? It uses less material. It is recyclable, and it's there's less wastage because it's a controlled environment. There's a quality controls in place and stuff. So these are the shifts which are happening in the construction industry. This is just something I put together recently as to what is needed to start a precast factory, so or organization. So number one is strategy. So if assume a big company, a real estate company or a construction company wants to get into precast, they need a strategy. They need a vision and focus on the strategy, and then they need to see how to implement the strategy. You need to have players implementing the strategy. Next comes in the organization and culture, which includes roles and responsibilities for the team, and the interface and culture for open innovation. So this is important to start up. And then the process, the life cycle management of the processes. You need to integrate design and detailing. You need to integrate your state-of-the-art manufacturing facility into the pyramid, and then quality control and research and development. And R&D is a major involvement in precast. You need to keep evolving. You need to keep changing your processes. Try to increase the productivity and the efficiency of these processes. The fourth will be the enabling factors. You put the process in place, and there are different enabling factors which come into a picture with BIM, project management, building information modeling, and supply chain management, and knowledge management. So how do you share knowledge with each other? How do you integrate the data which are available out there, and how do you manufacture something which is data driven, and put in these data in the your process, and how you improve on that. So, and the final result will be growth in revenue and profit, and you have happy clients, makes repeat business. So this is the pyramid. This is how companies can adopt the new shift, the shift which is happening. So why is precast an emerging market? Typically, emerging market is something which investors use to describe a developing industry in which investment would be expected to achieve higher returns, but be accompanied by greater risk. And so that is an emerging market. So the economy is making a transition. There is a rapid industrialization which is happening. There is a potential. We have the potential to be the next developed country in the world, and so this is where precast comes in. You can scale it faster, faster long-term economic growth than most developed economies, and this is where India is right now. It is growing at a faster pace for the past 5-7 years. We are growing at a faster pace than any other country in the world. So, we still have a lot of people who are in poverty, and there is the gap in between the highly paid and the low wage workers. And so for this, government needs to step in. They need to create housing for all, and they're doing that. And economically weaker sections need to be given equal opportunity to provide better infrastructure for them. And so that is why I feel precast is the emerging market. So I was talking about the opportunities and challenges. Every market has its own opportunities and now its challenges. So this is the opportunities I see, is that you can reduce reducing labor and material cost, thus reducing the overall cost with scalability. So that is one of the things precast has to offer. You're able to reduce the cost. Early adapters will gain bigger market share and experience, and that's where a lot of companies who started in the early 2010s, in that area, they've now fine-tuned their processes. They're ripe, to go big right now. And there are various companies in India which have been using precast and using precast to construct multiple projects, and Teenage being one of them, and which is local to our region right here. And there's Katera, or we used to be KEF before, now it's Katera. There's BME Precast, there's companies in Bangalore. They've adopted precast, much earlier, but there are new companies which are coming in. I understand Godrej is getting into precast. I hear Reliance Industries, they're trying to get into the precast business. So the big players are now kind of shifting. L&T they already have precast. Shapoorji has precast. BG Shirke has precast. So big companies that were adopted previously are trying to increase their market share with precast, and the new companies are coming into picture. The other opportunity available is the subsidy from government on using alternative technologies. It is not available right now, but the government is thinking about it. That will push this process very in a faster pace. The source of high-skilled but low-cost labor, and that's how you can increase in output. When you have high skill, when I say low cost, I don't mean that they're unskilled labor. They're skilled laborers, but because they have continuous employment, they come at and they have a proper working platform in the factories, and they have other wellness facilities. They are okay to be paid less than the labor at site, the day laborers, the people who work per day basis, or all that. And there's a great potential for joint ventures and acquisitions in achieving mutual growth. And like I said, bigger companies who have a lot of real estate in their kitty, and they want to join hands with construction companies precast companies, there's a great possibility here. So these are the opportunities which are available in precast. And the challenges. So these are the challenges which even today precast companies face. There are no codal provisions. There are no awareness of product in the general market. So very less awareness is in the general industry about the precast. They still think it's a new technology. It's still not in India and all that. Even when they go to the construction fairs and stuff, and they look at it as if they've never seen it before. So there's no awareness of the product, and of course the Indian codal provisions have not kept up with the new technologies. The second is the infrastructure of country needs upgradation. We need better roads, better development rules, setbacks, proper use of the wide roads which are not available yet. I think we are getting there, but that is a challenge with precast. We cannot transport precast to each nook and corner of the country because there's not enough roads to transport heavy materials. Scarcity of skilled labor at current scenario, and upskilling takes time. So, there are a lot of unskilled labor available. There are a lot of semi-skilled available, but skilled labor availability is still scarce in the industry. And the people who are shifting now, I understand that because of COVID, there's a lot of people who have shifted from Singapore, Dubai, Middle East countries who have greater skill level. And so I'm sure those people will be looking for employment, and precast companies and other manufacturing facilities will try to use those, because upskilling takes time. If you take unskilled labor and you try to skill them, it takes a lot of time to skill them in various facets of technology, facets of the construction industry. The last challenge is the cohesive movement by the general construction industry has not happened yet. Specifications are non-existent. Associations are not formed yet. So, like there's Builders Association of India, there's Indian Concrete Institute, but there's no Indian Precast Concrete Association. So, which is happening, it's not there. So there's not a general consensus among the industry that this technology needs to be adopted. People need to move towards it, and people need to push this. The architects are not aware of precast designs, precast products are out there. So these are the challenges which the precast industry faces. And the closing statements, I try to keep it short. So the precast is the future. It's here to stay, and let's adopt it. I think the earlier we adopt, the better we will be. So it is the future, and there's a lot of chit chat going on in the construction industry where a lot of people are saying that this is going to be the next big thing, and so we need to adopt it. We need to teach it to the kids and to the students who are in their engineering. They need to start understanding what precast is. It should not be an elective. It should be a full-fledged course, and it needs to happen. The formation of Indian Precast Concrete Institute is underway. And there's a WhatsApp group currently available, and precast companies have joined, and we are looking at starting up this association pretty soon. And ICI has a precast concrete handbook which they published, I think about 2-3 years ago, which was a good start. And I think we need to take it from there, and it needs to be pushed more, and it will help the industry overall. The next will be certification of the precast facilities and the labor which is available, and then creation of precast specifications and presentations to architect associations, and incorporate the designs, the modules in their system, which is very essential right now, because even today, it's been 10 years since I moved back to India, and even today we get projects which are detailed in the regular construction. They don't have an understanding of what precast can offer, and so that needs to change. And again, thank you to Builders Association of India and the professors who contacted me to give me this opportunity. And I think that's about it. And I'll get into questions, comments, suggestions, and this is my contact. Yes, hello. I'm going to stop sharing.
Hello, sir.
Yes.
Hello, sir.
Yes, hello.
Sir.
Hello.
Yeah, Sanjeev
Hello,
sir,
sir.
questions sir.
Sir, questionnaire time கொடுத்தலாமாங்க?
Yeah.
Okay, I requested all the participants for any queries. You can ask any queries to our resource person, and this is the time for your doubt and queries. Anything regarding PRECAST and our today's presentation, you can ask any of your doubts to our resource person Dinesh Kumar Bhandari sir, and he is waiting for your questions. Sir,
questions இல்ல.
Yes, sir. Sir, Bhandari sir, there is a message as a question, sir. In what way strength is imparted to PRECAST class?
I didn't understand what way strength is imparted to PRECAST.
Imparted to PRECAST labs.
I mean, PRECAST labs are either regular mild reinforced or they're pre-stressed slabs. So, what way strength is imparted? I didn't understand. What is that?
Hello.
Karthik Natarajan, sir. Resource person asking in what way the strength is imparted. The question. Come again with your question.
Why IS codes are not formed yet? Yeah, that's a good question for the people on the board. If you look at the Indian standards, they're pretty old. We adopt very late. I think that's why I say PRECAST is new in India, because people have not adopted. And I think even if you look at IS 456, I don't know, the last one was 2000 or something. After that, we've not got a new IS code even for concrete. So there's so much material out there, so much new stuff which has happened and we've not adopted. I think if the US market, they have a pretty well laid out plan where they come up with a new code every 3 years or 4 years. So ACI, American Concrete Institute, has a code for concrete which is 318, which comes out every 3 years, and International Building Code (IBC), which is overall the building code of the US, which it comes out every 4 years. So they just keep, adding stuff, removing stuff. Every 2, 3, 4 years, I think we need to keep doing that. And there can be easy committee codes which can be formed and codal committees which can be formed, and this can be done, but we don't do that. So I don't know why they're not formed yet. Can you say about the certification in precast concrete? Certification in the sense, I'm not sure, is it for the manufacturing facility or for the know-how of the precast? Currently, there, like I said, there is no association, there's nobody which provides any kind of a membership or anything with precast. And, the presentations and, the stuff, knowledge sharing happens, which is very at a minimal pace right now. So there's not a lot of people out there which can provide good data on what is available, what is not available. It is very scattered right now, but I hope that in the future, in a couple of years or so, maybe within a year, we form an association, and then we start training people. We start training the engineers. We start presenting it to the architects and all that, and hopefully it will improve. Upon your experience, what's the maximum span length obtained by ordinary concrete beams and pre-stressed concrete beams? Again, this depends on the depth available. So if you assume you have a 2 feet deep, a 600 mm deep beam, and if it's ordinary, it's just regular mild reinforced, I think you can go up to, say, 8 meters. If you take pre-stress with 600 mm deep, you can probably go to 12 to 13 meters span. And so it increased with pre-stressed. Is it possible to build intelligent buildings with precast concrete elements? Yes, it is. So, that's what I was talking about, data-driven technology, which is very easily done in precast. When you have a building information model, a BIM model to create the precast buildings, we transfer data from the BIM into the precast elements. Companies have started creating QR codes which are stuck to the precast elements, and they are there for the life of the elements. If you want to remove them, you can remove them, but if you want the QR code to be there, the QR codes can be stuck, and there is data which is available. Of course, there is not continuous monitoring of what is happening inside, but you would know when this precast element was manufactured, when it was transported to the site, when it was installed in site, and all that will be there in the QR code. There are other systems available where we install, strain gauges inside of it and see what is the creep, what is the all that other stuff. But currently people are using BIM to understand where steel reinforcement is. So you can look at the drawing when you scan that image, you scan the QR code, you can see what the drawing is, where is the steel reinforcement, where are the openings, ducts, everything. So these are intelligent building elements. Is it possible to do two-way slab in precast technology? Yes. Two-way slabs, typically long span slabs are one way, which is the hollow core slabs or double T's or stuff. But the filigree slabs, which I mentioned, which are like a 75 mm thick layer of concrete, which is cast in the factory, and then once it's transported to the site and installed on all four sides, assume a residential construction, they use filigree slabs, and it sits on four walls of a room, and they pour concrete, cast in situ concrete on top and connect it with the wall. So yes, it is possible to do two-way slabs, but the limitation will be the width or the length, one of the dimension of the slab, because you won't be able to transport two-way slabs more than, say, 10 to 12 feet, 12 feet by 12 feet. If you want a two-way slab, you cannot transport more than that because of the logistical restrictions we have on the highways and stuff. So that is all the questions I see.
செந்தில் சார் வேற ஏதாவது கொஸ்டின் இருக்கா இல்ல முடிச்சுக்கலாங்களா?
Sir, we can conclude, sir.
முடிச்சுக்கலாமா?
Conclude பண்ணுங்க, sir.
Okay, sir. Thank you, Mr. Dinesh Kumar, sir.
Thank you
for your valuable time. Thank you all. Thank you. Thank you.
Thank you for the participants, and thank you special thanks to the PAA team for organizing this event. So thank you, Dinesh Kumar, sir. Thank you very much.
Thank you, sir.
Sir, sir, left icon, sir.
Yeah, thank you. Yeah.
Thank
Bye.
you. Thank you.